When incorporating natural gas vehicles into your fleet, there are some key items to keep in mind in terms of your operations and maintenance facility. There are a couple of things to think about. First is a safety procedure shop plan for minor and major repairs in the facility. And second are the modifications to the facility required for natural gas engine repairs. Facility changes typically include selecting an area of the shop that would be designed for natural gas repairs, adding methane detection and air handling in the event of methane leaks, and modifications to electrical and heating systems. Here are several key elements that you'll want to consider as you assess your facility. First, a methane gas detection system, which will include a backup generator to keep the detection system running in the event of a power loss. Second, an air handling system for proper ventilation, which would involve opening doors and activating ventilation fans. Third, any needed upgrades to the electrical and heating systems. And fourth, making sure all safety procedures and restrictions are observed. We'll take a look at each of these key areas. Typically, in preparing a facility to service natural gas vehicles, you'll work with someone who has experience with natural gas service requirements.
So when we're assessing the building for the first time, you'll be having to provide some information to a consultant or a specialist that would help you walk through those processes. They take a look at the layout of your shop, so a shop drawing would be handy. Any type of AutoCAD drawing would be really good. They can do an actual layout and show where trucks would be parked, what type of work would be performed in certain bays. They'd map out where your methane detection systems would be. They'd also do a calculation on how big a ventilation fan is required and how many ventilation fans might be required to do the job. And then we have automatic door openers that would actually open doors. And all of that would be indicated on the drawing, and that would be the first step.
Whenever a natural gas vehicle is being stored or serviced in an enclosed area, certain safety measures need to be followed. It is important to understand these requirements and how they will apply to the service and facility plans. You should also check with your local authorities regarding local fire and safety regulations. As a reference, the National Fire Protection Agency publishes an industry standard, NFPA 30A, for natural gas vehicle facilities. They also provide a guideline for installation and inspection of natural gas fuel systems on vehicles, NFPA 52. Both of these guidelines are available at the National Fire Protection Agency website, nfpa.org. The natural gas vehicle industry also provides some service guideline reference material. The Clean Vehicle Education Foundation has published a paper offering guidelines for facility modifications for natural gas vehicles, which is available at cleanvehicle.org. And the Canadian Natural Gas Alliance has also published guidelines. To fully understand what may be required, it makes sense to first develop a safety plan for the facility. This would involve developing safety procedures for minor repairs, where the vehicle would be in the shop for a few hours with the fuel system closely monitored, as well as developing procedures for major repairs, which would have the vehicle indoors for an extended period of time and may require defueling the vehicle.
One of the first things you have to do is do a risk analysis, get a feel for what you want to do and how you want to do it, whether you're going to be servicing LNG vehicles or CNG vehicles or both. Take a look at some of the processes you're doing. Those will all be identified in what's called a shop safety plan. So probably the best place to start would be by developing a shop safety plan. So in your shop safety plan, you'll identify the type of activities you're going to be performing. Some of the activities can be done outside of the building, and some of the activities can be done inside the building. For instance, if you're going to be removing, let's say, high pressure cylinders or liquefied natural gas tanks, your plan may say that you're going to perform those functions outside of the building. And for other functions like replacing injectors or replacing regulators or high pressure lines, then we would be doing that type of activity inside the building, or for regular servicing like brakes, transmissions, those sort of things. The second step would be looking at what you're going to do for your shop in the event that you do have a leak. And then the third part of it would be, what do you do if there is a leak or there's an event? How do you deal with it from a safety perspective or from an evacuation perspective?
Natural gas is lighter than air, and so considerations about the proper roof height and ventilation are important. Gable or open web steel joint roofs are well suited for your facility, as gas will not pocket and ventilation systems can be modified. The air handling system will circulate and evacuate the air within the shop to prevent the accumulation of methane. Also, all electrical service should be relocated to be at least 18 inches below the ceiling. The ceiling height should be sufficient so that any leaked gas can rise above potential ignition sources. A ceiling height above 20 feet is best.
I think the roof design is probably the most important element of where we're going to be positioning the equipment and how much equipment is going to be put in. The roof design, basically you're looking at how many lights you have, what type of lights, are the explosion-proof lights. If they're non-explosion-proof lights, we can still work with that by cutting off the power at 10% of LEL. Also with the roof design, you'll be looking at other electrical supplies, other gas ignition sources, like open flame heaters, open and high temperature heaters are a no-no. That basically is something we have to avoid. So there may be a whole relook at the type of heating systems that you're using and the type of ventilation systems you're using. So basically anything that's open flame is something that automatically would need to be changed.
Gas detection equipment is required and a key element of the facility design. The system will be automated and linked to the facility's electrical and ventilation systems and shop doors. Typically, the methane detection system will sound an alarm at lower limits of methane to allow the system to be activated quickly and safely.
The basics of shop modifications probably start at methane detection. So primarily you'll have an alarm panel tied into a methane detection system. The methane detection system will then detect gas, and at the appropriate level, probably about 10% of the lower explosive limit of a gas leak, and that gas would be accumulating in the top part of the building. So when you're talking about the events of how everything works together in the event of a leak, a shop like this, for instance, will have an alarm panel. The alarm panel is tied into methane detection system. So the steps would be that the methane detection system would be detecting whether there was gas, stray gas in the building. If there is stray gas in the building for any reason, then the methane detection, 10% below the lower explosive limit of natural gas, so this is before it becomes explosive or ignitable, would then set a series of things into play. The first thing would happen would that the vent fans would probably kick in and air would start to flow out through the ceiling. The second thing would happen is the doors would open up. We'd have selected doors that were driven by explosion-proof motors. Those motors would manually open the doors in this shop to create an airflow from the ground up through the ceiling. And the third thing is there would be a shutting off of all of the lights and all the power, or maybe even all the gas in the top 10-foot radius of the ceiling. For those shops that have explosion-proof lights and all sealed connectors in the ceilings and all approved heaters, they probably wouldn't have to do that. For this particular shop, that's the path they've taken to make their shop safe.
Another important consideration in your facility design is the location of vent stacks that can be connected to vehicles in the shop.
For CNG shops, you may have a vent stack installed in your shop to take that last bit of gas out of a tank in order to take a high pressure gas valve out of a tank. For an LNG system, you have a vent stack. You can actually have maybe vent lines coming from your vent stack on your trucks that are mechanically connected from the truck to the vent stack in the event of an overpressurization of an LNG system, and then that gas can actually vent through the same vent stack that you would normally use for CNG venting.
In addition to the facility design, many shops add a level of safety and increase technician confidence through the use of personal safety equipment.
For some shops, they have the additional measure of personal safety equipment, where each technician may be wearing a gas detector on his hip or on his person, so that basically it would pick up any type of methane detection or lack of oxygen. So this is quite common in a number of shops, especially for those shops where they're dealing with working around gas and gas leaks. They would actually have that as an additional level of protection. And in this case, the actual technician may take it upon himself to hit an emergency button and actually manually trigger all of it we talked about before.
Of course, in addition to your facility design, a shop plan will ensure that technicians are trained and certified to work on natural gas fuel system components. Remember that a key requirement for the renovation of an existing facility or the construction of a new one is to meet the proper codes. Become familiar with the codes and standards required by your municipal, state, provincial, and federal agencies. Training resources include the Natural Gas Vehicle Institute, NGVI, which provides technical training, consulting, and information on natural gas vehicles, and fueling for fleet operator and industry members in North America. The website is www.ngvi.com. For CNG certification, technicians must complete the application process and testing requirements of CSA standards. The website is www.csa-america.org.